morning, everyone. I want to talk about what's remaining for the weeks after spring break, especially that time period between when we get back after spring break and the start of May when our AP exam is. So this is what I foresee in terms of what is left remaining as far as grades in the grade book. Okay, we're going to be working towards a 200-point pretest. Okay, but the pretest is going to be split up into a couple of things here. Remember how we've been doing homework assignments and have you guys been turning in? As a reminder, your assignments 8 and 9 is going to be due on Sunday. So the team's assignment is up, so you can hopefully get that in to get full credit. But now, each day that we do assignments, starting with today, they're all going to go into a test category. So every assignment, everything that you do in class is going to be something that you can turn in and earn points for. So every assignment is going to be 6 points each. And after everything is said and done, okay, there's no assignment during spring break. Today's the first assignment, but the second one is going to be the Monday after you get back. It's going to be like 15 or 16 assignments, 6 points each, and it's going to be total to be a 100-point test grade. So you'll be able to earn the 100 points just by doing homework. Should be an easy grade, right? Assuming that you're able to turn all these in on time. And I'll have you guys turn it in chunks at a time, just like last time, and I'll give you guys plenty of time, plenty of warning, so that you know when's coming up, when the due date is, and plan for it. But even if you don't turn in on time, just like these other assignments, you'll still be able to earn an A. It's not going to dramatically hurt your grade if you turn in late. So that's going to be part of the pretest grade. Okay. The other ones is going to be an FRQ test, which we're going to be working towards. It'll be 2 FRQs. It'll be the same length that we did our FRQ. The FRQ that we did yesterday is kind of like an extended one where I had 7 sections for one problem. This one is going to be maybe 3 sections per problem, 3 or 4, but just 2 separate topics, 2 pages. So similar to what you've seen in terms of the length. But I'm going to prepare you guys for those 2 FRQs. I'll specify what they are and we'll work towards them. Okay. The following Tuesday, we'll take a multiple choice test. Okay, so this could just be a wider range of topics over, just could be over anything, right? And so you can use your notes, but it just kind of gives you an idea as to the range of topics that can show up, right? I'm not going to say, okay, it's going to be this problem or this problem. We don't know what's going to show up on the AP exam, and so same thing here. But to account for the fact that in the past I would give, I would apply an AP curve on these tests. But 2 things here is that, one, we're not taking a full mock AP exam, right? We're just taking kind of like an abbreviated version of it. So instead of 4 days, I'm just putting it into a 2-day period. So to account for the fact that it's not full AP exam, and I still want you guys to be able to have some sort of a quote unquote curve attached to it, that's where the homework assignments come in. So if you can earn 100 points on your homework assignments, that's going to offset whatever grade you get here, right? And so that's going to act as your curve so this is all going to go together as 200-point test grade. Okay. So as far as I can tell, that is going to be the final thing that goes in the grade book for most of you. I don't know exactly what's going to happen. I don't have anything planned after the AP exam. I don't have any assignments planned or tests or projects. But unless they tell me that I have to do something, this is the last thing that I have planned. But I'm thinking maybe after the AP exam, if there are students who need extra support, they need to get their grade up to a passing, or they need to right? To try to get that, trying to get their grade up to passing. I'll probably be working with individual students to get that to happen, but I think for most of us, we should be done. As far as final exams go, everyone should be exempt, assuming that you guys have all turned in. You guys have taken every test and assessment that I've been given. Only if you've skipped an assessment, which none of us have, and for those who have, it's because of extenuating circumstances, and you're going to make it up sometime over the next few weeks. So everyone should be exempt. Most of us should be exempt from the final exam. So really, this is the only thing left. Okay. Every assignment is going to be the same length as what I've been giving you before. So every day is going to be 2 pages of notes and 2 pages of homework. Okay, and you're going to go through the same procedure. You're going to turn it in chunks at a time. Maybe I'll do like 5 assignments at a time, and you can try to get it all in by just taking 2 pages per photo, and that way you can get it all within 10 photos. So today is the first assignment, and then I'm going to be updating the website periodically over the break. So if you want to, you can definitely look to see the future assignments, and you can work on those and finish those if you like. But I'm not assigning anything over spring break, but it's your decision if you want to work ahead. But yeah, any questions? Everything seemed clear. Okay, so today I want us to focus on the 2 most recent units, which is going to be solving differential equations and volume area. It's pretty recent, but I just want us to get some practice in before the break, so that at least I can kind of jog our memory with these recent topics, have it fresh in our minds, and then when we come back from break, we can kind of just do a variety of problems from all over the place, and begin to start getting a feel for the type of free response topics, as well as multiple choice type questions. Okay. All right, so let's review the steps for solving differential equations. The first thing that I like to do is to cross multiply. And the whole purpose of cross multiplying is it resolves denominator terms, but it also gets the dy and dx set. Those are kind of acting as the anchor variables, right? If we can get those anchored down, then we can just kind of move things around to finish full separation. So once we cross multiply, we can at least get those 2 dy and dx set in their appropriate spots. Next step, divide the terms if necessary, right? We want to separate the variables, and the way we separate the variables is we want our dependent variables together. Any y and dy's, we're going to group those together on the left side of the equation. The independent variables, like x and dx or t and dt, they will be grouped together on the right side of the equation. Once you have everything fully separated, then you're going to explore integral rules for both sides. And you're going to treat each side independent of each other, okay? There are 2 separate problems, 2 separate procedures, and whatever it takes to take the integral. So the most common steps, the most common ones are power rule, or natural log, or U substitution, right? So those are, depending on how the problem is set up, those are the most common steps to handle each side. Now, once you found the antiderivative, make sure that a plus c shows up on the right side of your equation. And then you can work to either solve for c first or solve for y, but sometimes these are interchangeable in terms of the order. Sometimes it's easier or cleaner to solve for y first, sometimes it's cleaner or easier to solve for c first. But ultimately, you can do it in either order and you'll get the same answer. Okay. But we need to solve for C, get our general up to a specific solution, take the order pair that they give us and solve for C, and then we can solve for Y. Okay, so we'll do a very specific problem like that. This is from the 2018 FRQ number 6. But I also want to review linear approximation steps. Sometimes they like to group linear approximation concept with differential equations. So what we do with linear approximation, we're going to do two things, and those two things are highlighted in the name, linear and approximation. So our first focus is trying to find the line, trying to find that linear equation. So to find equation of tangent line, we need to find order pairs first. So usually they give us that information. Second, we need to find the slope. And slope comes from the derivative differential equation. So your differential equation, your dy dx, this is your slope formula. This is how you're going to find the slope. Okay. Once we've gathered our information, we're going to create our tangent line equation. Once you have your tangent line equation, then you've accomplished the linear portion of the process. Okay. Next step is the approximation. This is where you're going to take the decimal value. Well, first, if you solve for y, it's a little bit cleaner. You can just get y by itself. And then replace your x with the decimal value, or the decimal, and then that will lead you to your approximation value, and that's your linear approximation. So a lot of times we can go through this process without even doing any calculus, right? Take our order pair, find the slope, point slope, decimal. Okay, so let's practice that with part A here. We have a differential equation that's given. Let y equals f of x be the particular solution to the given differential equation with initial condition of 1, 0. So there's our point. Write an equation for the line tangent to the graph of the function at x equals 1. Right, and then use your equation to approximate f of 0.7. So let's gather some information first. Order pair we have, so that's just 1, 0. Slope comes from the derivative equation, but I'm going to put that here. Slope m equals, I'm going to fill in that space later. So it's going to come, my slope is going to come from my derivative equation. So I'll take my order pair and dump it into dy dx. One in for x, 0 in for y. One-third times -2 squared. 1/3 times 4, which is 4/3. And that's our slope. All right, so I think we have enough information where we can create our tangent line equation. And we can start taking our general and move it into the specific equation here. So y minus 0, slope 4/3, x minus 1. Solve for y. Normally I would just take this number and move it to the right side, but that's a 0, so this is going to drop out. But normally I would try to, move anything away from that y. All right, we've accomplished the linear portion of our process, and now we're going to move on to our approximation. So look at the decimal that they gave you, and you're just going to take that decimal value and dump it into the x of your equation. Okay, into the calculator this goes. And we should get negative 0.4. Okay. Any questions? Okay. In the homework, I had another one of these so you guys can kind of practice that process. Sometimes you may see this on the multiple choice section as well. They may be kind of presented a little differently. So maybe over after we get back, I'll have just a variety of multiple choice questions where we kind of get used to the concepts that we know how to do and apply it to solving specific multiple choice questions. So hopefully we can get a lot more practice with multiple choice after we get back. But I feel like the my initial goal is to get us more comfortable with FRQs. I think the tendency is, most students think they just have a natural feeling that there's a safety net with multiple choice because there's answer choices available, and typically they're more concerned about FRQs. So that's why it's nice to get that FRQ quiz out of the way. You can kind of get get your feet wet, and then we'll continue to kind of build on that knowledge and get comfortable with how they ask questions on FRQs, and we can save the multiple choice for a little bit later. Okay, so let's look at part B. Find the particular solution to the given differential equation with initial condition of 1, 0. So we're going to follow these steps here, and we're going to try to go through and solve this differential equation. So what I like to do is I like to set up, make sure I get two fractions cleanly, so I can just have it like a over b equals c over d. So I want to clean up this right side so it just gives me a clear fraction that I can cross multiply. So rewrite my equation here. I'm going to push that 3. I'm just going to put that 3 below the x and the y minus 2 squared. Okay, cross multiply. So I'm going to pair the diagonals together, and I'm going to pair it in a way where I'm going to target the dy's first, right? Naturally, I'll just be able to get that dy in their right spots. So I'm going to target whatever has the dy, so it'll just be locked in on the left side. So 3 dy. So I like to cross multiply first because I can get these sets, right? I may not get full separation, but at least I have my anchors down, and I know everything else is just going to be working around this, right? I know those are there to stay. They won't be moved. If there's any movement, it's going to be things around it, but not those two things. Okay. So now the next step is, can we get full separation? So what do you see? What needs to be moved? Mm-hmm. And the well, the dy is there to stay, but we can just move the 3. Right, okay. So I'll say this: the y minus 2 squared, that definitely has to be moved, right? Because that's out of place. We want the y's on the left, so we have to move that. The 3 is more of a suggestion. I like to move it, but it's not wrong if you don't move it. It's just that typically we know we're trying to get that left side we want to eventually solve for y. So any unnecessary things that's on the left side, I'm just going to move it to the right side. Allows me to clean things up through the problem rather than waiting to the end. So I'm going to do two things here. I'm going to divide the 3 over, but I'm also going to divide the y minus 2 squared over. So I'm going to do a kind of like going to have them just shift spots. So on this side, I'm going to divide by 3. But this side, I'm going to divide by y minus 2 squared. I'm just going to make them swap places. So I'm left with dy over y minus 2 squared. And then I'll divide the 3. Okay, so we've accomplished full separation and we moved unnecessary things from the left side to the right side. So basically any coefficients. Okay, getting to this point is the most important step of this problem. If you can't get to this step, you're not going to earn any points after this. Okay, so we need to be able to do this, right? If you mess up later with the integral process, or you solve for c incorrectly, or you're not able to solve for y, at least you've earned some points, right? You've earned at least a few points because you've learned how to separate the variables, right? So that's key. If you can't separate the variables, you're going to lose all these points here. A lot of times these are just like like more than half the FRQ points are just within this solving here. So, all right. So now we have full separation, and now we can explore integral rules for these sides here. The right side is pretty straightforward, right? That's just the power rule problem. We can handle that later. But the left side, this is a little too messy for us to just jump into any sort of an integral rule. So we got to first go through what? Yeah, use substitution, right? Anything that looks messy with a function within a function, anything like that, on the integral side of things, we don't call it chain rule, we call it use substitution. So our u value is just that portion inside the parentheses. So we let our u value be y minus 2. We do du over dy. Y becomes 1, 2 goes away. We solve for dy, which is du. Okay, we make our substitutions, replace dy with du, replace the y minus 2 with u. Looks like there's no coefficients to keep track of, so we don't have to worry about any coefficients that needs to be pushed out. Okay, so just going to move to the top here. I'm going to keep both sides at the same level. Even though the right side is ready, I'm just going to kind of keep it at the same stage. And I suggest it because maybe it's not going to impact your answer. But I think keeping both sides at the same level is good for when you're going back and double checking your work. It's easier to follow your work for yourself if everything's at the same level. It's harder if you're staggered in terms of you take the integral on one side, but then the other side is still sitting before it. It's hard to look at and decide if you're doing it correctly. So keep everything on the same level is my suggestion. Now, the right side is ready for power rule. The left side, it's cleaned up. But what rule is necessary to handle this problem here? Just power rule. Good. We don't do natural log. We only do natural log if it's u to the first power, right? If there's no exponent or that exponent to the first power, then it's natural log. But if it's anything else, it's going to be power rule. But is it quite ready for power rule yet? No. Okay. We make an adjustment, right? Bring that u to the top. So we're still doing a little bit of cleanup even after u substitution. Now we're ready. Okay. So with integral rule for power rule, we add 1 to the exponent. We divide it by that new exponent. So negative 2 plus 1 is just negative 1. I can move that down. So here's my antiderivative cleaned up, and then I'm going to replace the u back in terms of y. So here is my cleaned up version on the left side. Okay, so the left side is ready. The right side, we know it's just going to be a small little power rule problem here. X becomes x squared over 2 with the 1/3 in front. That comes out to be x squared over 6. Don't forget, plus c. Okay. All right, if you can get to this point, you should be pretty happy because you've earned a bunch of points here up to this point. Solving for c is not difficult, so I would just go ahead and solve for c. If you can solve for c, it'll just give you a point right there. So yeah, make sure that we always take that step to solve for c. All right. My order pair is 1, 0. 1 in for x, 0 in for y. One half is equal to 1/6 plus c. Subtract 1/6 from both sides. 1/2 minus 1/6, same thing as 3/6 minus 1/6, which is 2/6, which is 1/3. So c is equal to 1/3. Oh, by the way, I just want to bring this to your attention. This is part of a non-calculator section. Okay. On my pretest, I'm going to let you use your calculators. That's fine. But just to give you a heads up, this is non-calculator. If you're asking, wait, what about this? This is not easy to do without a calculator. So my answer to that is leave your answer here. Right? If you leave your answer unsimplified, you get full credit. Right? So there's no need to do any sort of thing here. You know, the only thing messy here is having to subtract these fractions, right? So you got to do this without a calculator. So that's the only thing on the AP exam. On the pretest, fine, you can use your calculator, but just want to make you aware, calculator, non-calculator sections. Okay, so there's my C value. I'm going to update my equation or my general equation here. So I'll plug 1/3 in for C, and then we can decide what to do from there. All right, any questions so far up to this point? So we've done most everything, right? We've separated the variables. We took the integral. We did use substitution. We solved for C, but we have one final thing that remains, and that's solving for y. Okay, getting y by itself. Now I want to talk about this for a moment. On the AP exam, time is really important, right? You want to spend your time wisely. And what I mean by that is sometimes you get to the point where it may not be worth the effort to spend a ton of time just trying to get 1 point, right? You've already earned most everything here. And I'm not saying to not work on this. I'm just saying maybe if there's something more pressing, go ahead and do that, right? Because this is only 1 point, you know, maybe in 5 minutes, you could be earning 3 or 4 points elsewhere on another FRQ. So my suggestion is if you see that something doesn't seem like just a 1 or 2 step process to the end, save it, right? If you feel like, oh, I may need to think about this in terms of moving things around, but there's only 1 point remaining here. So why not spend time elsewhere? And if you have time left over, come back to this one. right? So just want to continually think about how you want to spend your time on the AP exam. I think though, if you take the June exam, you may be stuck with having to just do one problem at a time. You may not be able to move on to another one until you've completed the one that you're on. But at least on the paper pencil test, on the paper pencil test in May, you'll get to move between problems as long as it's within the section. So there's 4 FRQs in the non-calculator section, so you can move between those 4 problems and you kind of decide, jump back and forth between those problems. Every problem you have 15 minutes allotted, so you have a full 60 minutes to move between those 4 FRQs. Okay, but for now, we're going to work through it. I just want to kind of talk about how sometimes you may want to spend your time elsewhere before you come back to just earn this last point. So I'm looking at this going, all right, I would like to get this to be matching fractions so that it makes it easier for me to work with. So what if I just get this right side down to 1 fraction by getting a common denominator? So I'm going to get that 1/3 to be 2/6. Then I can get common denominator. Now, I want to solve for y, but y is a little bit out of place, right? It's in the denominator. So you could cross multiply and divide and try to get that y by itself. But I'm looking at this, and I was just thinking, well, if I can just flip this fraction, I can get that y minus 2 up top. Then it's easier for me to work with the y. But if I flip this fraction, I can flip this other side as well, right? Then I'm making everything balanced. So that's my way of getting a little bit of a shortcut here. Okay, maybe there's other ways that you want to rearrange it, but that's, to me, is the fastest way to just try to get that y up top. And then that -1, I can just move to the other side, right? If I multiply everything through by -1, I can just force that -1 to be on the right side. I can drop the denominator, and so okay, so maybe it's not that many steps, but you can imagine how sometimes algebraically it may take a few starts and stops before you can solve for y. Yeah, and you just have to kind of weigh that decision on your own, right? Is it worth spending this much time? Or if it's quick, then finish it. But if it's going to take a while, then maybe come back to it. Okay, any questions? All right, so we did a differential equation problem. Let's talk about an area volume problem. Let's go to the back. Okay, so finding area, finding volume, this is the final unit that we did before AP review started. So area is just simply top minus bottom, right? You find your 2 boundaries of your graph, and you do either top minus bottom or right minus left, depending on what that relationship is on your graph. And then we just take the integral, right? That will ensure that we can always get a positive value out of it. And then we moved on to volume. Volume, we explored this method, washer method, and cross section. So this method and washer method are related in the sense that we're always rotating about an axis, which essentially is going to create these circular disks or circular rings, and we're just accumulating these disks or rings from one end of the spectrum to the other. Something that we had to pay attention to was what direction the axis of revolution is. Is it a horizontal axis of revolution, or is it a vertical axis of revolution? If it's horizontal axis of revolution, we always have to make sure that our radius is perpendicular to it. And if it's a vertical radius, typically we prefer that because we know that it's a little bit easier process. We don't have to do any adjustments with the equations. Every equation that we see is pretty much ready to use. But things get a little dicier when we see a vertical axis of revolution. That means we have to draw our radius horizontally. If you ever see a horizontal radius, you know, okay, the equations that's provided to me is probably not set up and ready for me to use. I need to rearrange it. I need to rewrite the equation. I need everything in terms of y here. So the left side has to take on the form of x equals. All my equations will have that form of x equals. Okay. And then cross section is where we're inserting into an integral, but we're no longer dealing with circles. We're dealing with different shapes that we're building on top of a base. It could be a triangle, it could be a semicircle, it could be a rectangle, it could be a square. Okay, so let's start with number 2. Oh, and then let me just talk about this method and washer method again here. This method is where there's no gap between the axis of revolution and the shaded region. So if you don't see any gaps, that means we only need one big radius. But for washer method, you can tell that we need washer method when there is a sizable or distinct gap between your shaded region and your axis of revolution. If you see that, then we got to rely on 2 radius. I only put washer method up here because if you can memorize washer method, which essentially is just subtracting 2 circles, right? Big R pi r squared minus pi little r squared. If you can memorize washer method, then you're basically staring at a part of the disk method, because if you cover up little r squared, then that's basically your disk method right there. Okay, pi big R squared. Okay, so let's look at number 2 here. We have the region R enclosed by the graph of f of x. So here's the curve. And the horizontal line y equals 4. So that creates the shaded region. Part A. Find the volume of the solid generated when region R is rotated about the horizontal line y equals -2. So we're rotating. We know that this is going to be a disk or washer method. That's my axis of revolution. Okay, so let's go ahead and draw that and convince ourselves whether this is going to be a disk or washer. Okay, so what do you guys see here? Disk or washer?
Yeah, disk. Or washer.
Yeah, washer. Yeah, we see a gap. I think the only place that we're going to see a disk is if the dotted line was up here, up against this flat surface, right? Then we don't see any gaps. Then it's going to be this method. But here, anywhere else, even if it's touching the curve, that's still a washer method. It needs to be up against a flat surface, right? If you see any sort of a gap, we know it's going to be washer. And if it's washer, we know we need to rely on 2 radius. We need a big radius, and we need to subtract out the little circles. So we can write down washer, and we can draw our 2 radius. Remember, your dotted line is the center of your object. This shaded region is going to end up circling around this. So imagine this is a ring, and you need to stick your finger through it. So this is the center of your object. Okay. So that means if you want to draw the radius, your radius has to extend from the center outward. So start on a dotted line, extend to the furthest boundary of your shaded region. That's going to be your big R. Little r, extend from the dotted line to the closer of the 2 boundaries. And now let's create the expressions that will represent big R and little r. So big R, top minus bottom. So the top is sitting at the y equals 4. And the bottom is sitting at the y equals -2. So 4 minus a -2. And then we'll do little r. Little r is also top minus bottom. Top is sitting on the curve, and the bottom is sitting at the -2. So the top is the polynomial here. So okay, we can do a little bit of cleanup, but we're going to start putting this into our volume formula. So we see top minus bottom here. These are vertical radius, so we can just depend on this first formula. But we're still missing the bounds, right? We have to find our two bounds, x1 to x2. Okay, the left bound is easy, right? That's 0. But the right bound, we got to rely on the calculator. Okay, so this one is a calculator question. This has to be a calculator question here. So if you have a 36 Pro, you can do numsolve and plug in both equations and give yourself a starting point that is maybe somewhere in this region. You may not know exactly where that value is, but you know that if it hits 0, that means you need to go further out and give it a starting point that's closer to that intersection. But on the graphing, I'm going to just plot both graphs into and under y1 and y2 and see if I can make the intersecting feature find that for me. So I have my equation filled out under y1, y2. I'll go to zoom 6 just so I can get a basic picture as to where it is, and then if I need to zoom in, I can do that. It's a little bit small. I'm looking for this intersecting point there, so I'm going to do zoom box, option 1. Hit enter. I'll pick a point where I can begin drawing my box. I want to pick a point that is on the upper corner of my box, and then use my arrows to drag above and below until I get my box here. Okay. Find that intersecting point by going to second trace, which will take you to calculate, and then choosing option 5. So second trace will take you to calculate. We want to find the intersection between these two graphs. Hit enter. And now you're just going to scroll over to a point that is close to the intersection that you're interested in. Hit enter. Blinking cursor will be on the other graph. Make it close to the intersection, hit enter. And finally, there's our intersection. We care about the x value, so x equals 2.3. All right, I think we have enough to create our volume equation here. I forgot the pi here. So pi, integral from 0 to 2.3. Big radius squared, so big radius, 4 minus -2, that's just going to be 6. Minus little radius squared, I have some like terms that I can put together. 4 minus -2, that's also 6. Big parentheses around it though, right? And all this will just go directly into your calculator. Did you guys get 31.471 pi? I've been having you guys put pi next to your answer, right? I said not to enter pi in the calculator. So that's fine on free response. But I just want to kind of talk about how on the multiple choice section, you may be getting this answer, but then your answer choice is not matching this. And the reason why it's not matching it is because your answer choice may have already multiplied the pi through. So just be aware of that. You know, that pi there is really times 3.14. So your answer choice may be sitting at 98. When you're trying to figure out where is that number showing up, is because the answer choice already had multiplied 3.14 through. So, but on the free response, either form is fine. All right, part B. Region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis is an isosceles right triangle. So we're doing cross sections here. The isosceles right triangle with leg on the base, I put the formula above so you can see it. So our first goal is to figure out what the base is, right? We want to figure out what is the expression for that base length. First up, though, we need to know what direction to draw the base, right? Do we want to draw it vertically? Do we want to draw it horizontally? And it shouldn't be a guessing game. They'll tell you exactly how they want you to draw it. So they say each cross section perpendicular to the x-axis. Right? So x-axis, that's horizontal. You want something perpendicular to it, so we must make it vertical. So I want my base to be a vertical distance between the two boundaries of my shader region. So I'll do top minus bottom because it's a vertical base. So 4 minus the polynomial. We can clean that up in a little bit, but just make sure you have a set of parentheses here because we got to distribute this negative through. Okay, so we know that it's going to represent the base length that we're going to be building on top of this, on top of that surface. Next is we need to figure out what area we're using, and we're using the 1/2 base squared. And then we can just take the integral of this expression, right? We have the area formula now. We just have to accumulate that area from one end to the other. So volume is equal to, there's no pi, right? We're no rotation here. So just integral of 1/2 base squared, my base. If I clean this up, distribute the negative through, I get 4 minus 4, which will take this out. So just negative x to the 4th plus 2.3x cubed. Okay, I'm ready for my calculator. Oh, my bounds. My bounds is going to stay the same. So from 0 to 2.3. Okay, remember your bounds is restricted to just your shader region. It could be area, it could be disk method, it could be washer method, it could be cross section. Your bounds will always stay the same as long as our orientation is either is consistent. Your bounds is not going to change across different problems. Okay, if it's the same shader region, if it's the same orientation, top minus bottom, you're going to get the same bounds across all the problems or all the variations. So we should get 3.574 as our volume. All right, now part C. We haven't talked about this. I kind of skipped over this, but it's not a hard concept, but it is something that we may have to revisit after the break. Let me read part C here. Part C says, the vertical line x equals k divides region R into two regions with equal area. Write but do not solve an equation involving an integral expression whose solution gives the value k. So we want to split this up into two equal regions. But this is not a geometric shape where there's not a symmetrical geometric shape where you can just see where that dividing line is. So we want to create an equation where we can maybe solve for a k value that represents kind of like the center where the dividing line that allows the two regions to have the same area. So if I just eyeball it, I know it's going to be somewhere between here. So I'm going to just pick a point here and draw a vertical line and just call it x equals k. So the idea is that we draw a line and we want to, wherever that k value is, that's going to allow for this region on the left to be equal to this area of the region on the right. Okay, so we just have to create an equation that represents that relationship. So we'll say, we'll create an area formula for this region on the left. So we know that this is top minus bottom, so we'll do from 0 to k. Top minus bottom. The line is consistently above the curve, so 4 minus. Now, I don't want to write the whole equation out again, so I'm just going to call this f of x. So 4 minus a polynomial, 4 minus x, sorry, 4 minus f of x. So this integral notation will represent the area of this left shaded region. Okay. All right. What do you think is the integral that will represent this second region? Integral from where to where? Good, k to 2.3. Yeah, I point to the 4, but it's 2.3. Yes, from k to 2.3. Is top minus bottom going to be the same? Yes, right. 4 minus f of x. Okay, so this variation is not difficult because we're not even asked to solve. We just have to create an equation that where if we were to solve it, we'll be able to solve for k and figure out where that dividing line is. Now, having said that, there are problems where we have to solve for k, and these are typically problems where we got to do it by hand. We can't plug in the calculator. We got to go through power rule. But it doesn't show up every year, so that's why I'm kind of picking and choosing the important topics first, and then I'll go back and revisit this one. So maybe working this out by hand, there's different variations of these k problems that, or x equals k problems that we can do, but I'll probably just hit them randomly over the course of the 3 weeks that we have before your exam. Okay, so this is part of your first assignment. We didn't get to do number 3. I think this is a good one to do because this forces us to do a right minus left, and we got to practice knowing how to rewrite our equations. So maybe we can start with this the Monday after break, and then I'll have other worksheets for us. But I'm going to be uploading the key pretty soon. So if you want to get a head start, finishing up the homework, that's your decision. But ultimately, you can wait till after spring break because nothing is going to be due the week after spring break. The first batch is going to be due the Tuesday, the week after we get back. So yeah, there's plenty of time. But please take the time to turn in your assignments 8 and 9. These are freebie points here, so get those in. But ultimately, if you can't get it until late, you'll still get a 90 on it, but why not get 100? So, all right, that's all I have. Hope you guys have a wonderful break. I'll see you once you get back. Oh, and by the way, it's going to be virtual the first 3 days. So Monday through Wednesday is virtual. So I'll see you guys on Teams. Okay. All right. Thanks, everyone.